Hi everyone, and welcome to this presentation on how to create with the Sandwizz Breadboard. The Sandwizz Breadboard looks like this, and it might look a lot like a normal breadboard, but we have built a lot of stuff into that will differentiate it from the normally traditional breadboard and just make it so much easier to create with that. I'll come back to that. First, when we should make such a application, we'll need to have some kind of schematic tool, and we are using KiCad. That is an ECAD system. It's free and open, and also it goes with Mac, Linux, or Windows. So whatever flavor you like, you'll be able to download it and run this here. Then you start to build, and we will provide some component in the library here in the KiCad that we ensure is compatible with the Sandwizz Breadboard. And some of the components will be quite traditional transistors like this, but others will be components that is here with yellow, that is built in to the Sandwizz Breadboard, embedded in there, and can be utilized when needed. So for instance, here we're building a class B amplifier, and we want to take a sine wave tone here and amplify that through the class B amplifier and then get it out of the speaker here. So we make such a schematic, and when that is done, we will just go in and export this as a netlist. A netlist is a textual way to describe how each component are interconnected and which components are in there. So we export that netlist, and we just call it by default the amp with op amp transistor, and we save that. And now that this is saved, we are good to go to upload it to our breadboard. The breadboard is the one you see here underneath the camera here, and I just need to connect it to my USB. I do that with the PC. There we go, and you see we get a welcome screen here that says we can just press any key. We'll do that, and then we get a menu here telling that the die temperature of the breadboard is around 23 Celsius degrees at the moment, and we are running very close to 5 volt. The voltage is something that we can adjust, and we can look at that afterwards. Now we need to upload the netlist that we have generated, so we press the number 3. When this is pressed, we go in here under connections, and we say we would like to send this file, and we just need to press here all files, and then we get the circuit that is the format, and then we double click it, and we will see the uploading take place. Now we have the option here that we can see the raw netlist that were generated from the KiCad. And when we look at that, we will actually see up here that this is the raw netlist, and it's generated from the KiCad schematics. And then we see the reference out here. Here we have a transistor, then we have the net labels, and then we have the type or value of the component. So that's the whole deal, but netlist can be a bit hard to read because you have all the net labels, and it can be hard to see how they interact. Now we press any key here, and we get back to the menu, and then we can make a process netlist, and that's really where all the algorithm is placed for the Sandwizz Breadboard, where the magic takes place. So we press number 2, and suddenly you will see it's in with the same references, and then we have pin references here, and you see that we have a built-in, this is the built-in operational amplifier. This one has some fixed pins, and these pin numbers are actually referring to the numbers you see here on the breadboard. So if we have number 17, that would be around here that we have 17. So there we would have the plus for the operational amplifier, and for instance for the output would be 21, so that would be down here that we have this one. So this is fixed, and then we have the transistors, and as they are with 3 pins, we try to keep them first, so we should not stretch the pin apart. For the capacitors and resistors, there it's more agile, and there we will be able to stretch them a bit more. But we say that in general we shouldn't stretch them more than like 4 holes in down here somewhere. If it should stretch more, then we will utilize internally silicon wire, so we do not need an external jumper, and we do not need to stretch the components too much. So that's how it's done. So now we have that, we go in and we want to build this one, and we have this wizard, and the wizard, what it does is actually it tells you step by step where to place which component, and then it also tests if it's correct inserted. That's like the process here, but we'll take it straight and just see how it's done. Okay, this will be optimized in the final firmware. Here it asked me to place the internal operation amplifier. Yeah, that's already done, and that should just more be like an information that this is done. Then we take the first, and I'll move to the side here, and we take the first transistor Q1, and it's into the pin 7, 8, and 9. And as we have the reference 5 here, you will see that 7 will be somewhere there. We take the transistor and put it in here, placed. We'll take the next, it went well, and we'll take next transistor, and then we'll place that here, 9, 10, and 11. Done deal. Then we'll go to the next one. It's the capacitor, 9 and 12. So that would be a common leg for the transistors, and number 9 should be up here, and then we have number 12 there. Yes, done deal. Then we have a test point, and if you look over here, the test point is actually where the speaker should be connected, also test point 2 and the speaker itself. Those we will not connect at the moment, neither the speaker, because it comes with some wire and it will obstruct our insertion of the other components, so we'll wait with that. Then we have an internal component again. It's the functional generator. That one should be like more information in the final firmware. And then we have the capacitor here, and that one we take and place it in 15 to 17. 15 to 17, that's right here. The next one is a resistor, and this resistor goes from 16 to 17. 16 to 17, that should be like here. And the next one, 17 to 18. 17 to 18. That is then placed. We'll take the next one, 19 to 20, a resistor, and I'll take that resistor and put it into 19, that's here, to 20. The next one is the diode, and I'll take the diode and place it. And of course, if it's misplaced, turn the opposite direction, the system will tell you that you need to turn this diode, so you have the anode and cathode the right way. Placed. The second diode, and I'll take that one. It should be in 21 and 22. 21 and 22, that's here. And then finally we have our 4, and our 4 should be placed here. Now all components are placed, and we go out here, and one thing we did, or I did forget, was to mount this speaker. So I'll take the speaker, place it on the desk here, and then I'll take the wire, and maybe we do not recall where it would place, so we'll just take the processed netlist and you'll see here, okay, yes, the function, let's see, the speaker is here, so that's number 12. And we'll take 12 here, somewhere, that's of course right here at the capacitor. And then we could put it into number 13. That's a ground, but as this is with a quite high power, I will prefer to put it into the common ground that we have down here. Now it's mounted. Putting it into this where it did suggest that I should put the loudspeaker into number 13, and 13 is right here. And yes, 13 will be ground because every pin will either be able to be ground or VDD or something else like a signal, digital signal or analog signal routing. That's also why we do not have any power rails on the side on the Sandwizz Breadboard, because every pin can act like that. But there are some limitations, so if we go quite high in power, and we do that in the amplified signal here with the speaker, then this ground that we make with the pins might be not, it might be with too high impedance, so that's why we're using this one down here instead. Okay, that is done, and we go back, and now it's time to start the circuit application. It's turned off by default, and then we start it by pressing 5. And there we go. We hear a sine wave being generated here. And this one should actually run around 500 Hertz. And I have a test generator here, and I'll pop it up here so you can see it. It should be somewhere here. There we go. This is just an application that I have on my phone where I can do a fast Fourier transformation of the sound in the room, and if I acquire it, you will actually be able to see that we have a tone there that is pretty much 500. There you go. And also what we call harmonics, those tones, that is harmonic, higher tones, you can see they are quite low, so we have a quite good sinus wave coming out here. So now this is done, we could try to do some other stuff. One of the things we could do is actually go into the instrumentation part, that's number 7, and there I could select my voltage. And right now we are running pretty much at 5 volt, 4.99 volts. That I could lower by pressing the default buttons here. We can also take it step by step, but let's go to 4 volt. And then let's go to 3 volt. And now you will hear a change in the tone. And going back to our Fourier transformation, you will actually see when we go down in voltage, we will get more of these harmonics. And that's due to the fact that we start to get some clipping because the power rail will be too narrow, and then the signal will start to saturate because it gets up to the top or down to the bottom here. So that's a good like indicator that when we lower the power, that actually we can do lowering of the power from the firmware, the interface here, but also that we get this phenomenon called clipping. So let's lower that one and go back. We are still running at 5 volt. We can now go out in instrumentation menu, and then we can actually go into what is called graph plot mode. When you start here, you'll just see a bunch of number running here. The neat thing about the CoolTerm, and it's really cool, is that it also have a chart mode. And there we see a lot of things going on here. We cannot really see what it is, but we can zoom in chart properties, and there we could go in and say, well, the x-axis, we want to have that fixed. Let's say it should be around 20 samples, and then we go in there and then we see some kind of curve. Right now, this is a very first build that we have done and utilized this with the CoolTerm. So it is not with a high sample rate. This will be improved. It's in our backlog, and it will come later on with a firmware upgrade with the bootloader, and then you will get a much better graphical display doing this. But already now we can do measurement, and the measurements can be done on every single pin here by software, moving that around and say, well, now I want to probe this one. So that's a neat thing we have here. Going back to plain text, and then I press escape to get out. That's some of the functionality we have here. One more thing is, of course, we can stop the application. I'll now press 6 and I'm out here, and then we would have some other options down here. If we press 8 here, we can actually go and reset the system like that. But we can also go in and do a bootloader of the new firmware. It's done by pressing 9, and yes, I would like to bootload. Then I have a Host Bootloader software. It's right here, and there I go in and press I want to connect to this USB part, and then I just press program, and then it will go into this directory where I have placed it until this is the new firmware. And this firmware, whenever we at MicroAware have an upgrade, this will be, of course, public, and you can go down in and download it and then upgrade it and program your Sandwizz Breadboard with that. So there we go. It's now programming in and should be ready. Yes, now it's ready. And now you see we have a new screen here. Press any key to continue. We'll do that. And then we have a bootloader running. Now the next thing I would like to show is actually that it's called the Sandwizz Breadboard, and that's for a reason. The reason is that we could actually take other modules and put them in here. And one of the modules we have, I have the raw PCB here, is actually for Arduino Nano, and some might call it a shield, but we call it a library board because it's a library of components that we put on here, and with a connector you can put that on here, and suddenly you have connections of your Arduino directly up here. More about that in another video, but I want to demonstrate what it can do. So if I go in now and I'll again run the application, you hear the sine wave going there, and then I have my Arduino Nano here, the code. And right now you see there's a program here, and it's just based on the very simple blink application you get from the Arduino environment. I made a slight modification, so when I'm blinking low all the time. Now I will go in. What happened here? Something, yeah, okay, here. Now I will go in here and I will take away this, so now I go both high and low with this output pin. When I do press upload, of course I should plug in the Arduino. It's not plugged in yet, but that will be. There we go. Let's see if it can do the connection. I hope so. Uploading. It seems like something is going on. It's done uploading. And now suddenly you hear the tone is shifting. And that's because what is not shown here is that we do have a digital input on this component here, the function generator, and when it's low, it plays 250 Hertz, and when it's high, it plays, no, it's the opposite. When it's high, it plays 250 Hertz. When it's low, it's plays 500 Hertz. So if we go back and look at our there you can see the shift in the two frequencies. And now we actually have a system that interacts, where we can take an Arduino and do something with the component inside the Sandwizz Breadboard. This is a very simple application where we have just a digital input, but we will synthesize components where you can, through an API, actually from the Arduino, write directly to these components and ask them to do whatever settings configuration that we want. So if you wanted to have it to 200 Hertz, then I just send a command 200 Hertz for this, and then it will be up running. So that's more or less the whole process of building with the Sandwizz Breadboard. And yes, is it a real application we have here? I wanted to show that. Let's try to start it here. And if I take out a component, it could be the transistor. Will it still work? No, of course, it will not be functional anymore. Now I'll put it back in, and there we are up running. So that's the whole concept. And do not worry if you do not know yet, if you are like a beginner in electronic and you do not know how to build Class B amplifier. We will provide a lot of application where you can take those and just download this for either it could be for the KiCad, so you can see the schematic, or you could just take the netlist that we provide, and then you will get the information about where to place and which component to place, and everything else we will take care of, and then you will be up running building your own amplifier.